Okay, so at the end of the last question, if you punched your numbers in correctly, you should have gotten 37.96 meters per second. That's number 6 on the more kinematics questions. Number 7, you watch as your friend passes a slow driver on the highway going 134 kilometers per hour. By the end of the passing lane, you need to switch that into meters per second. And so divide by 3.6, and when you do, you get 37.2 repeating meters per second. Then he sees a police car and ends up slowing down to 100 kilometers per hour. Again, you have to change that into meters per second, and it becomes 27.7 repeating meters per second. He slows down in 5 seconds, wants the acceleration. A is equal to VF minus VI over delta T. So the VF is 27.7 repeating meters per second minus the VI, 37.2 repeating meters per second divided by 0.5 of a second. Okay, and so when you do the math, keep all your repeatings, divide by 0.5, and you should get 18. Oh, what am I looking for? You watch your friend, how far did he travel in this time? I found A, which you would need anyway. So his A is 8 negative 18.8 repeating meters per second squared. The negative means he's slowing down. So now we want to know how far did he travel. So you could do either delta D is equal to VI delta T plus 1/2 A delta T squared, or you could do VF squared equals VI squared, either one. So I don't have to rearrange, I'm doing the delta D one. This is 37.2 repeating, multiplying it by 0.5 of a second, 1/2 the A, which is negative 18.8 meters per second squared, and by 0.5 seconds squared. So delta D equals, so multiply by 0.5, multiply by 0.5 squared. That's your second term, and then you're going to add it to your 37.2 repeating times 0.5, and you should get 16.25 meters. Okay, number 7. Number 8, you're driving this time, and you're going 126 kilometers per hour. So again, switch that to meters per second by dividing by 3.6, so 35 meters per second. This one we already found above, 27.7 repeating. And the question wants you to find how much time did it take. Okay, so you have a VF, a VI, and a delta D, and you're looking for time. First, we could find acceleration by doing VF squared is equal to VI squared plus 2A delta D. So VF squared minus VI squared, and then divide by 2 delta D. And so we have A is equal to VF squared minus VI squared over 2 delta D. So the VF was 27.7 repeating meters per second, and that gets squared. The VI is 35 meters per second, and that gets squared. And it's over 2 times 62.77 meters. So we get our A. So 35 squared. And then what's it was 27 squared. And then divide by 2 times 62.77. So you get negative 3.611. Let's say 6. It's 5. I'll keep all the digits in my calculator. And again, the negative means slowing down. Okay, but that's not what the question asked. The question asked how much time. And so now that we have an A, we could use A is equal to VF minus VI over delta T. So delta T is equal to VF minus VI over A. So delta T is equal to, my VF was 27.7 repeating, my VI was 35 meters per second, and my A is negative 3.6116. Keep all the decimals in your calculator. So delta T is equal to, so that number in your calculator is be your answer button, so you can bring it back in a minute. And so do your 27.7 repeating minus 35 and then divide by the answer. And when you do that, you should get something very close to 2 seconds if you don't round. All right, that is number 8. The last one I asked you to do was number 9. And number 9 says, I am fast is speeding down the interstate at 45 meters per second. I guess I am fast is speeding 45 meters per second. Looks ahead and observes an accident which results in a pile-up in the middle of the road, 72.5 meters in front of her. By the time IM slams on the brakes, 0.5 seconds has passed. So this is like a two-part question from yesterday. There's going to be the reaction time, and then there's going to be the slowing down. Okay, so for the reaction, IM's VAV is 45 meters per second, and the time, it tells us, is 0.5 of a second. Okay, she slows down at a rate of negative 10 meters per second squared, so A is negative 10 meters per second squared. The VI under slowing down is 45 meters per second. How far will she travel before she stops? VF is 0. So you need to find the delta D in both pieces. So for this one, VAV equals delta D over delta T. So delta D equals VAV times delta T. So it's just going to be 45 meters per second times a half a second. So the delta D of the reaction time, 22.5 meters. Over here we can use VF squared is equal to VI squared plus 2A delta D. Rearrange for delta D. So VF squared, my pen's dying. VF squared minus, they're both dying, VI squared over 2A. Okay, what's going on? And that's going to be delta D. So delta D is equal to VF is 0. I must have a pen here somewhere. Wait, I have a pencil that I could switch to. So negative, the VI was 45 meters per second squared, and that was 2A. 2 times negative 10 meters per second squared. So 45 on the top gets squared, divided by 20. The two negatives cancel out. We get a delta D of 101.25 meters. What's your total delta D then? 101 and 22, so 123.75 meters is the total when we put these two together. Unfortunately, IM saw the barrier 72.5 meters in front of her. Definitely not good. Definitely not. Okay, so those were all your homework questions. The next video is going to be with the examples. Okay, so we did 3 examples yesterday in class. I'm going to do a video with probably the next 3. Okay, and then you can do your homework. So hopefully these guys helped. Find these sheets, and I'll be right back.